All right, guys, welcome back to another video. Now we're working question 5 on the June 2019 paper 2 mathematics. So it says the cumulative frequency distribution of the volume of petrol needed to fill the tanks of 150 different vehicles is shown below. And they gave us the table with the volume and the cumulative frequency. And it says for the class 21 to 30, determine the lower class boundary. So what we know about boundaries is that the lower class boundary is 0.5 lower than the lower class limit, and the upper class boundary would be 0.5 higher than the upper class limit. So therefore, what we know is that the lower class limit here is equal to 21 and the upper class limit is equal to 30. So therefore the boundaries is equal to, it would be 20.5 is less than or equal to x, where x is less than 30.5. So this would be how the boundaries are basically represented, and in this case our x is our volume. So therefore 20.5 would be our lower class boundary, and if they had asked 30.5 would have been our upper class boundary. So therefore lower class boundary is equal to 20.5. Part 2 now asks us for the class width. So a formula that we can use for the class width is our class width is equal to the upper class boundary minus the lower class boundary. So therefore class width is equal to 30.5 minus 20.5. When you do that, what you'll get is the class boundary to be the class width to be 10, and that is our class width. Part B now asks us how many vehicles were recorded in the class 31 to 40. So 31 to 40, they gave us a cumulative frequency of 101. What we know is that if they had given us frequency and if we were calculating cumulative frequency, usually it would mean that we're adding the previous cumulative frequency plus the upcoming frequency, and that would have given us the cumulative frequency for that group. So it would have been 59 plus whatever frequency there is, and that would have given us 101. So what we're going to do is to write a formula to represent that. So how many vehicles were recorded in the class? It would have been 59 plus x, which is the upcoming frequency or the frequency for the class 31 to 40, and that gave us 101. So what we're going to do is to solve for x. So we're going to subtract 59 from both sides of the equation. So what we're going to have is x is equal to 101 minus 59, and therefore x is equal to, when you do that subtraction, what you'll get is 42. So therefore 42 vehicles were recorded in the class 31 to 40. Part C now says a vehicle is chosen at random from the 150 vehicles. What is the probability that the volume of petrol needed to fill its tank is more than 50.5 liters? And it says leave your answer as a fraction. So the probability that the volume of petrol needed is more than 50.5 liters. So what we know is that 50.5 liters would have correspond with the upper class boundary for the class 41 to 50, and it would have been the lower class boundary for the class 51 to 60. So therefore, what we need to know is how many vehicles were recorded basically in this class, the 51 to 60, and that would have given us the question asks how many vehicles required petrol that is more than 50.5. So we want to know how many vehicles are required a volume that is greater than 50.5, which would have been in this class of 51 to 60. So what we're going to do is then say number of vehicles that required more than 50.5 liters would be equal to, we're subtracting the cumulative frequencies, that would have been 150 minus 129, which will give us 21. So 21 vehicles required petrol that is more than 50.5 liters. So therefore, now looking at the probability, remember probability is what you're interested in, which is vehicles that required more than 50.5 liters over the total amount. So probability of vehicle chosen at random that required more than 50.5 liters would be equal to, what we're interested in is the number of vehicles that required more than 50.5, and that would have been 21 over the total amount, which is 150 vehicles. So therefore, the probability is therefore equal to, this can be simplified, so we can say 3 into 21 goes 7 times, and 3 into 150 goes 50 times, and this is our answer, leaving it as a fraction. So the probability is 7 over 50, and that is our answer for part C. Part D now says, Baron estimates the median amount of petrol to be 43.5. Explain why Baron's estimate is incorrect. So what we know is that there are 100, the cumulative frequency is 150, which is 150 vehicles. So therefore, the median would be half of the cumulative frequency. Which should be equal to a half of 150, which should be 75. So therefore, the median is in the 75th position. So therefore, when we now look back at our table, the 75th position would fall somewhere in this class of 31 to 50, as the highest, the frequency stops at 59. So therefore, the 75th position would be within this class where the highest cumulative frequency is 101. So therefore, it would be between this volume of 31 to 40. So the 75th position, or the value, corresponds to the median. So the 75th value lies in the class 31 to 40. So therefore, in now calculating our median, what we need to do is to find the middle value, the middle volume for this class right here. So therefore, what it will be is, so therefore, median, so let's change this rather to median position. So this would be median position. And then this now would be where the median is. So therefore, median is equal to the 31 plus 40, and that is divided by 2. And when you do that, what you'll get is 31 plus 40 is 71. So it is 71 divided by 2. And when you do that, what you'll get is 35.5, and this would be liters. So therefore, Byron's estimate of 43.5 liters is incorrect, as the median is 35.5 liters. Part E now says, on the partially labeled grid below, construct a histogram to represent the distribution of petrol needed to fill the tanks of the 150 vehicles. So what we know is that for us to complete this, we had needed the frequency for each group. As you see, the question gave us the frequency on the y-axis. So we're plotting frequency against the volume. So what I went ahead and did was to calculate the frequency for each group. So we know that the first cumulative frequency is always equal to the frequency of the first group. So the frequency for the first group is 24. And then to get the other frequencies, as we had done in 2 questions above, you're always subtracting the previous cumulative frequency from the current frequency. So it is 59 minus 24 to give us 35, 101 minus 59 to give us a frequency for this class of 42. And then for this class of 41 to 50, the frequency would have been 129 minus 101 to give us 28. And the frequency for the last class is 21, which is 150 minus 129. So what we know is that we'll be plotting using the boundaries for each class. So we're using the lower class and upper class boundary to plot each group. So therefore, for this of class of 11 to 20, the lower class boundary is 10.5 and the upper class boundary is 20.5, and the frequency is 24. So we're lining this up at 10.5, and the upper class boundary would have been 20.5. So right here, 20.5, and we have a frequency of 24. So that would have been our first bar on our histogram. The next one is 21 to 30. So the lower class boundary is 20.5, and that is how histograms are connected, as they share common boundaries. So this then would have been 20.5. The lower class boundary for this is 20.5. The upper class boundary is 30.5, and the frequency is 35, which would have been here. The next one is 31 to 40. So it would be 31. The lower class boundary is 30.5. So therefore this will be connected. So there should be no space between here, guys. So it should be some amount of overlapping. So it will be 30.5 and to 40.5, which is the upper boundary, and the frequency is 42. So this would come up to here. And then the other is 41 to 50. So the lower class boundary is 40.5. The upper class boundary is 50.5, and the frequency is 25. 8. So it would be 25, 26, 27, 28. And that would have been our bar. And for the last one, it is 51 to 60. So our lower class boundary is 50.5 and our upper class boundary is 60.5 and the frequency is 21, which would take it right here. And this is what a representation of what your bar, your histogram will look like. So thank you for joining us, and we'll see you for question 6.